Day 363 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we got question number 2071, maximum number of tasks you can assign. The difficulty level is hard, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go on and check out that link in the description so you can get you some. Now let's see what the question says. You have n tasks and m workers. Each task has a strength requirement stored in a zero-index integer array task, with the ith task requiring task of I strength to complete. The strength of each worker is stored in a zero-index integer array workers, with the jth worker having workers of j strength. Each worker can only be assigned to a single task and must have a strength of greater than or equal to the task strength requirement, i.e. workers of J has to be greater than or equal to tasks of I. Additionally, you have pills, magical pills that will increase a worker's strength by strength. You can decide which workers receive the magical pills, however, you may only give each worker at most one magical pill. Given the zero-index integer arrays tasks and workers and the integer pills and strength, return the maximum number of tasks that can be completed. All right, y'all, so I can understand how that question may be difficult to understand. So let's go ahead and take a look at these examples just to make sure we are doing this problem correctly. So in example 1, we have the input task equals an array of integers 3, 2, and 1. Workers equals an array of integers 0, 3, and 3. Pills equals 1. Strength equals 1. Output is 3 because we are able to complete all three of these tasks. And now let's look at the explanation so we can see how we're able to complete all three of these tasks. We can assign the magical pill and task as follows. First, we give the magical pill to worker 0. So we have pills, we have one pill, and it gives a worker a strength of 1. So we can assign the magical pill to worker 0. Boom. So we give worker 0 the magical pill, and now worker 0 has a strength of 1. Once worker 0 has a strength of 1, we're now able to assign worker 0 to task 2 because 0 plus 1 is greater than or equal to 1, right? So once we assign worker 0 to pill, now worker 0 has a strength 1, and now worker 0 has enough strength to complete task 2, which requires a strength of 1. So now that's one task that we completed, that worker 0 completed, because it has we gave it a magical pill and it has enough strength to complete task 2. After that, we assign worker 1 to task 1 because 3 is greater than or equal to 2. So after that, we come to worker 1, which has a strength of 3, and assign that to task 1 because that has a strength of 2. And since 3 is greater than 2, that means worker 1 has enough strength to complete task 1. Now remember, these are zero-index arrays, so this is task 0, this is task 1, this is task 2, this is worker 0, this is worker 1, this is worker 2. So after we assign task 1 to worker 1, worker 1 completes task 1. Now we have completed 2 tasks. Then finally, we can assign worker 2 to task 0 because 3 is greater than or equal to 3. So since worker 2 has a strength of 3 and task 0 requires a strength of 3, we can assign worker 2 to task 0 so he can complete task 0, and now that's a third task that has been completed, and in total there's 3 tasks that have been completed. That's why the output is 3, because we were able to assign a worker to each one of these 3 tasks, and all 3 tasks were able to be completed. So I hope that made sense to y'all. If it didn't, don't worry. We're going to go over example 2 just to really bring it home and make it make more sense to everybody. So, excuse me, y'all. So in example 2, we have task equals an array of integers 5 and 4, workers equals an array of integers 0, 0, and 0, pills equals 1, strength equals 5. So we have one pill that has a strength of 5. The output is 1. Explanation says we can assign the magical pill and task as follows. So first we're going to give the magical pill to worker 0. So we take this one pill that we have and it has a strength of 5. We give it to worker 0. Now worker 0 has a strength of 5. That allows us to assign worker 0 to task 0 because 0 plus 5 is greater than or equal to 5. So now that worker 0 has a strength of 5, we can assign worker 0 to task 0 because task 0 requires a strength of 5 to complete. So boom, we got task 0 completed. That's one task completed. But as you can see, we have 2 more workers, but they have 0 strength, and it says right here, each worker can only be assigned a single task. So that means we can't use worker 0 to complete the second task. We have to find a new worker, one of these workers, to complete the second task. And since none of these workers are able to complete the second task and we're all out of pills because we only had 1 pill, then no more tasks are able to be completed, and we were only able to complete 1 task. So thus, that's why our output is 1. So let's go ahead and take a look at example 3 just to really make it make sense in case it doesn't make sense yet, where we have a few larger numbers, a few more pills, and let's see what we can do with the how many tasks we can complete with example 3. So in example 3, we have the input task equals an array of integers 10, 15, and 30. Workers equals an array of integers 0, 10, 10, 10, and 10. Pills equals 3, strength of 10. So we have 3 pills that add 10 extra strength to each to our workers. The output is 2 though. And the explanation says we can assign the magic pills and tasks as follows. So first we're going to give the magic pill to worker 0 and worker 1. So we give worker 0 a pill and we give worker 1 a pill. So now worker 0 has a strength of 10, worker 1 has a strength of 20. Boom. Then we assign worker 0 to task 0 because 0 plus 10 is greater than or equal to 10. So now that worker 0 has a strength of 10, worker 0 is able to complete task 0 because task 0 only requires a strength of 10 to complete. So that's 1 task that we're able to complete. We can assign worker 1 to task 1 because 10 plus 10 is 20, which is greater than or equal to 15. So remember we gave worker 1 a pill as well, so now worker 1 has a strength of 20. With the strength of 20, worker 1 is now able to complete task 1, right? So now that's 2 tasks that we've completed because we gave each of these workers pills, and which gave worker 0 enough strength to complete task 1. So that's 1 task completed, and it gave worker 1 enough strength to complete task 1. Boom. Worker 0 can complete task 0, and worker 1 can complete task 1 because worker 1 now has a strength of 20, and task 1 only requires a strength of 15. So that's 2 tasks that we can create. Now it says the last pill is not given because it will not make any other worker strong enough for the last task. So as you can see, we have 1 more task here to complete, but it requires a strength of 30. Now we have 3 pills, so we have 1 more pill to give after we gave it to the first 2 workers. We still have 1 pill left with a strength of 10, but as you can see, if we give the pill to any one of these workers, at most one of these workers will have a strength of 20. Like it give maybe worker 2 20, worker 3 20, or worker 4 20. But either way, 20 is not enough strength to complete the last task because the last task requires a strength of 30. So there's no need to even give out the last pill. We gave out 2 pills and we were able to complete 2 tasks after giving out those 2 pills. So since we were able to only complete 2 tasks, our output is 2, and that's why. So I hope that made sense to y'all. I know it's a lot to take in, but hey, that's what we're here for, to learn. So now that we understand the question, y'all, let's get into the fun part, the actual solution, y'all. Solution is not that difficult either. So first thing we need to do is we're going to come outside this main function. We need to create a helper function. So for that, we're going to say private func, we could call it check. We're going to open up the parentheses. We're going to say underscore tasks, colon. That's going to be an array of integers. Come outside of that, we're going to say comma. We're going to say underscore workers, colon, That's going to be an array of integers as well. Then we're going to say comma. Then we're going to say underscore pills colon. That's just going to be an integer. Excuse me, integer comma. Then we're going to say underscore strength colon. That's going to be an integer as well. Then we're going to say comma underscore mid colon, and that's going to be an integer as well, and it's going to return a boolean. Then we can open up our brackets. Boom. Now, first thing we need to do, we're going to say let m equal workers dot count. Then we need one for the pills, so we're going to declare a variable called p and set that equal to pills, and that's going to keep track of the remaining pills for us. Then we need a pointer to the strongest available worker, so we could just declare a variable. We call it ptr. We'll set that equal to m minus 1, and then we need a dq to store eligible workers for the current task. So we declare a variable called ws. We can set that equal to dq less than, then it's going to be integer, greater than, and put the parentheses at the end. Boom. Now we need to iterate over the mid or the hardest task from hardest to easiest. So we're going to say for I in stride, open up the parentheses, from colon mid minus 1 comma through colon 0 comma by colon -1. Boom. We're going to come outside of that. We're going to open up the brackets. Now we need to add workers who can do the task with the pill to the front of the DQ. So we're going to say while, open up the parentheses, ptr is greater than or equal to m minus mid, and two and signs, workers, square bracket, ptr, come outside the square bracket, plus strength is greater than or equal to task, square bracket I, come outside of this parentheses, and we're going to open up the brackets. Boom. Then we're going to say ws dot prepend, open up the parentheses, workers, square bracket, ptr. Boom. Then we're going to decrement ptr by saying, come underneath this, and we're going to say ptr minus equals 1. Then we're going to come right here underneath this while loop, and we're going to say if ws dot is empty, then we're going to open up the brackets, and that means no available workers for the task, so we could just say return false. Boom. Else, if ws dot last exclamation point is greater than or equal to task, square bracket I, come outside that, open up the brackets. So if the strongest worker can do the task without a pill, we're going to say ws dot remove last parentheses. Then we're going to come right here, and we're going to say else, open up the brackets, the worker needs a pill to complete the task. We're going to say if p equals 0, then that means no pills are left, so we can say return false. However, and then we'll come underneath this, and we can decrement pills by saying p minus equals 1. Come underneath that, and we're going to say ws dot remove first, open up the parentheses. So we're going to use the weakest valid worker and apply a pill. Boom. Then if all tasks are successfully assigned, meaning we went through all of this, then we could just come right here and we could say return true. Boom. But we're not done yet though, y'all, because that is just our helper function. We still need to get into the main function and call this helper function. So for that, we're going to come back up here to the main function, and we're going to get the number of tasks and workers by saying let n, set that equal to tasks dot count, comma, then we're going to say let m equal workers dot count. Boom. Then we need to sort the tasks and workers to allow greedy matching. So we're going to say let tasks, let tasks equal task dot sorted, put the parentheses, comma, workers equal workers dot sorted, and put the parentheses. Boom. Now we're going to use a binary search bounds for maximum number of tasks we can assign. So we're going to say, we're going to come underneath this, we're going to declare a variable called L, set that equal to 1. Then we're going to say comma R is equal to the min, open up the parentheses, M, comma N. Then we're going to come outside of that, we're going to say comma, and we're going to say ands. We're going to say ands equal to 0. Boom. Now we're going to use the binary search to find the maximum number of tasks that can be assigned. So we're going to say while L is less than or equal to R, we're going to open up the brackets. We're going to say let mid, we need to find a mid, so we're going to say let mid, equal, open up the parentheses, L plus R, come outside of that, and we can divide that by 2. Boom. Now we're going to call our helper function and check if it's possible to assign mid task. So we're going to say if check, open up the parentheses, tasks, comma, workers, comma, pills, comma, strength, comma, mid. Come outside of that, we're going to open up the brackets. We're going to say ands equals mid, comma, to update the answer. Then we're going to come underneath this and try a higher value if we need to. So we're going to say L equals mid plus 1. Else we need to try a lower value. So we're going to say right here, else, open up the brackets, R equals mid minus 1. Minus 1. Then we could just come right here and say return ands. So let's go ahead and give this a run, y'all. Make sure it runs properly before we submit it. Okay, so what does it say? Oh, sorry, y'all. Won't need 2 lets. We could just do it like this. Let's run it again now, see if that works. See what happens, and it's accepted, y'all. So let's go ahead and submit it. Make sure it's still accepted after we submit it, because if you know how LeetCode can be. And look at that, y'all. 51 milliseconds beats 100% of users with Swift. That's what I'm talking about. Those are the numbers I like to see. So before we get out of here, y'all, make sure you get one more look at the code. This is the top part of the code. This is the main function. This right here. This the top part of the helper function. This the bottom part of the helper function. And yeah, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.